Hello. Yeah, guys, can you hear my voice? Okay, till now we have discussed a lot of things in programming, and just we are left with just a few topics, and like just few main topics. So loop we have already discussed, and so for your quick introduction, I just wanted to have a do while loop, and then like something called continue and break is always there, and then function, and like some part of functions like especially the recursion. So I will try to introduce these things today, and like main things that in the C programming a lot of there are a lot of things related to function, then the loops, but since our main focus is the CMI, so we will just take that part only from which we can solve the like previous year questions and solve the questions that is asked in the CMI. So there are a lot of things, lot of different types of way to define the function, different type of way to deal with the function. But the main thing with the function is that you should know how to define it, how to actually how to pass some values using the function, and how actually recursion work. And if you have been given a problem of recursion, then if like let's say there has been some code given, then you need to find the output to that particular code, okay, how this particular output is working. So we will see a lot of things in this class, and we'll also look at some problem that is asked in the CMI itself, or related to programming. And I think there will be uh, I think one more lecture for the programming part, and then we'll move to the probability. So, and then we will keep coming to this programming part once a week or twice a week, sometimes, to just keep revising, do some problems, or do some left topics if you want. So these things will actually allow you to do a lot of questions. So we'll actually be seeing one, two, three questions in this class also, and see how we can solve those questions. Okay. So just 1 minute. Okay, so let's start with this do while loop. So in last class, I actually introduced the concept of while loop, and then we have seen what is the for loop. So these two loops are mainly used, mainly like in the general world, people use for loop, and any problem that can be deal with the while loop can also be deal with the for loop, and vice versa. But do while loop is something, some means it's something different from the while loop. Okay, so how it is different? So like a do while loop has some difference, and a while loop and do while loop may seems like same for you, but these two loops are different. So in do while loop, what happens first? If some statement is given inside the do while loop, so the syntax is do, then curly braces, then write some statement, then close the curly braces, then write while, and inside the while write some condition, okay, and then put semicolon. So this is the way you write the syntax of do while loop. You will write do, then in the curly braces you will write some sentences what you need to do, and this is just a simple English sentence. And then in the while you'll write some condition to be true, and then semicolon, okay. Second thing is that the do while loop will actually first run the code. So like it's like do something and then check, okay. So what it will do, when this particular code is given, it will run the code first. It will run the code without checking the condition, and when this particular code is run once, then what it will do, it will just check the condition. If the condition is true, it will again run the code, and if condition is not true, it will not run the code. But in while loop, what it was happening, that in while loop, as you remember, so while loop will only run when the condition will be true, okay, when the condition will be true. But in do while loop, nothing like that. So in do while loop, what happens, the code will run once. So एक बार तो कोड रन करेगा, the once the code will run, and then it will check the condition, okay. That's why there is a difference between do while loop and while loop, and there are some scenario where do while loop can be more important than while loop. So those things are based on questions or the problems that we will give it. But the main thing is that do while loop just to run the code once, then check the condition. So at least when the condition is also wrong, at least code will run once, okay. For first time, code will always run in the do while loop. So that's what has been mentioned here, in while test condition before executing any the statement within the loop, but do while loop test the condition after having executed a statement within the loop. So let's say, we'll see with example. So main difference is that first the code will run, then the condition will be checked in the do while loop. But in the while loop, what it was happening, first condition will be checked. If it's true, then the code will run. So let's say if condition is false here, then the code will not run. But if here the condition is false, at least once the code will always run. Okay, so let's understand this thing better with the example. Okay, so we have been looking at some examples. So for this problem, just now focus on the we are trying to find, we're trying to find, a simple interest of simple interest, let's say 4 times or 5 times. Okay, so what's the way we can do? Just first, initialize a loop counter. So this is a loop counter that we all already know. So you initialize a loop counter, and then do. So do will be what it we have to write. You write the some sentences, some statement. So you will take the value of p and r, then you will just define whether it's float or int, and then you will just take the input and you'll take the simple calculation, and then you will print the value of that developed at simple interest, and then you increase I plus plus. Okay, so I plus plus means whatever the loop counter is, you will increase it by 1. Okay, plus 1 it will you will do. Okay, then what will happen, it will check a condition while I less than 5. So yes, if I is equal to 0, at the next step I is equal to I will be equal to 1. Okay, so I will equal to 1, so it is less than 5, so it will run the code again. Let's say if I here is equal to 9. Okay, I instead of 0 is 9, then again it will, at least it will run the code once, and then it will change the I, which will be 10. And if you will check again with the while, 10 less than 5, which is false. Okay, so it will not run the code again. So it means whatever the code is, whatever the condition is, it will run the code once, and if its condition is keep means it's true again and again, it will keep running the same code. Okay, so this is what do while loop do in the C programming. So as part of the flowchart, we can see that you have some program, you initialize the program, then what happened, first the body of loop is run, then you will do some increment, and then you test some condition. If it's true, then you again repeat the same procedure. So this running of code part and increment part is done first. Okay, it is done first, and then you will check the condition, and then if it's true, then you run the code. If it's false, you will stop doing it. So this thing allow us to do loop by 3 ways. So there is for loop, there is while loop, and there is do while loop. So these things are always there in the C program, but mostly whatever the problem you'll be looking at, actually either it will be from for loop or while loop. Okay, so this thing will be there. Any problem, anyone? Okay, I told you, there are two other statement there: break statement and continuous statement. So let's say you are running a particular block of code, and you encounter uh, sorry, not the continuous statement, you encounter a statement, you want to, let's say you are running a particular block of code in a loop, and you want to exit out of loop based on some condition. Okay, so it can be used with a variety of ways. So first let's example. So let's say you want to check a prime number. Okay, so want to check if a given number is prime number or not. So what you can do in this case, the first thing is that you will take a n input number integer from the user. And what you will do, the simple way our prime number can be checked is, start from I is equal to 2 till the number. Okay, and what you need to do, uh, you need to keep dividing this number by each I. Okay, so what you have to do, if num so if num and modulo I double equal to 0. Okay, so let's say the number is 6. So 6 is not a prime number because it is get divisible by 2 also, 3 also. So any number is prime number if its divisibility is by 1 and itself. Okay, so when we know that, okay, we know that if any of the numbers from 2 to num minus 1, divide this particular number, it is not a prime number. So we know that we just run the loop from I to num minus 1. We divide by each I, and then if we get any such I, we need to print that it's not a it's not a prime number. Okay, and we need to end that code there because we don't want to continue else. So let's say it's a let's say 90. Okay, so we get 2 is dividing the 90. Okay, 2 will be dividing the 90. So there is no point to checking if 3 divides 90 or not, or 4 divides 90 or not, or 10 divides 90 or not, because we know that if any number we get apart from 1 and itself that can divide the number, we know that it's not a prime number. So that's where we don't want to continue for with the rest of loop. That's where the like break statement is important, because what the break will do, break will instantly come out of the loop. Okay, so let's say how this thing is working. So let's say we want to check if the number is prime number or not. So we define a number. Okay, we take the input from the users. We started I is equal to 2, and what we are doing, we are just taking number from 2 to num minus 1. Okay, and we are dividing the number by I. Okay, so first I is number will be divided by 2, then 3, and then what so far the num minus 1 is. Okay, and again it's what it's doing, if any number, if any I is dividing the I a number, it will give it's not a prime number. Okay, because you know that if any number divides a number apart from 1 and itself, that particular number cannot be a prime number. Okay, so it will print prime number. It will set a flag is a variable. It will set flag to 1, and then it will be break. So what this break will do, whenever the break is encountered in the loop, the program actually comes, like it was running in the loop, it will comes out of the loop. So program execution will become here. So no part of the loop will be again run again anymore. So whenever the break is encountered, the execution of the program comes out of the loop. Okay, so now it will check there if flag is equal to 0 or not. So let's say ki if it's a prime number. Okay, so let's say it's a 7. Okay, so we know that any number between 2 to num minus 1 will not divide 7. Okay, so this particular if condition is not true, and at the end of this program the executions come out of the program. Okay, and we know that here ki it's 7 has not been divided by any number. So like in the beginning itself we set a flag is equal to 0. So what this mean, what do you mean by this flag is equal to 0? So when you set flag is equal to 0, it means if the number is a prime number, not a prime number, then we set flag is equal to 1. Okay, so it is a part of checking whether the number has been divided by any number or not. So if this condition has not been run any times, okay, so this flag will be equal to 0, what we have been initialized in the beginning itself. And then at the end we will check if flag is equal to 0 or not. If it's 0, then we are talking about a prime number. And if it would have been divided by any number, let's say it would have been divided by 3 or some other number, we'll set the flag to be 1. Okay, so we will again check at the end if the flag is equal to 0 or not. So this is the way, like a flag part is actually a common thing in the programming, where you want to trace a condition. So you are tracing here that if the particular number was divided by any I or not. And why it's important, it's important because at the end you also want to check if it's a prime number or not. So you just can't put an else part here. So it's simply people would get, if it's not true, then put an else part. But this is not the way, because let's say if number is not divided by 2, then the else part will be printed. But that's not true. Now you have to check for any number between num and num minus 1. So that's why this flag part is important. You just put here to check if it's a prime number or not. So is this concept clear with you all or not? I can see that it's actually a like a thoda sa tedious code, but just let me know if it's any problem there. Yeah. Yeah, yeah. No, no, no. No, break is not due to the flag part. Okay, just for now, just forget about the flag thing. So let's say forget about this particular thing. Okay, just forget about this thing. There is no such thing. Okay, so we have given input. Let's say 12. Okay, so what the program will do? Uh, uh, I will be initialized with 2, so it will check with the number divides 2 or not, because it will start from the 2 only. Okay, so this condition is true, right? Because 12 is divisible by 2, right? So we know that it's not a prime number, so it will print not a prime number and it will break out of the loop. So break is because that particular number is getting divided by any I or not. So is this part clear or not? And then let me explain the next part. Okay, now let's say. Mhm. Okay, so let's say now I put a number 11 there. Okay, so 11 is there, so it will check for 2 is not dividing 11, and it will keep doing this thing from 2 to 10, 2, then 3, then 4, then 10. Okay, and what we will do at the end, any number will not divide I, so this break will obviously not get executed, and the program will come out of the loop. So if any number is not a prime number, we will get the output. But if any number is prime number, how we are going to check it? Okay, that's why the flag part is important. There are other ways to check if this number is prime or not, but like obviously this is one of the way. Just to set the flag is equal to 0. If that particular number has been divided by a number, then just set flag is equal to 1, because at that point of time we know that we have counted a means composite number. Okay, and if that particular execution has not been done, so let's say ki any number is not dividing 11. Okay, we know that still flag is equal to 0. Why flag is equal to 0? Because that any number has not divided the whatever number we have given, so that number must be a prime number. That's why we are checking this thing in the end, and we are printing if it's not been divided by any number, the flag would have been 0, what we have been initialized initially, and it would have been a prime number. Is it clear now? So there are multiple other ways to check this thing also, but this can be one of the way. Okay, so there is something called continue statement also. So break and continue are there. So like continue continue part is not like some people use generally, but break is something that you will encounter in the real life problem also. So continue statement, what it will do, so let's say we are running a block of code. Okay, so let's say there are like 100 lines of code, and in the third line you have a continue statement. Okay, for like all the break and continue statement come inside the if loop, sorry, if block. Okay, so if there is a if block, and break or continue will run only when some condition of if will be true. Okay, so this thing is by default, this break will or this continuous statement will be get executed if some if statement is true. So let's say we have a continuous statement in the third line of this particular code. Okay, so when this particular continue statement gets run, what happens that it will not come out of the loop. So like in the break condition, what the thing was, it will just come out of the loop. But this is not the way. What it will do, it will just skip the rest of the code, and the execution will come to the beginning of the program. Okay, so let's see this with a simple example. So let's say we are just trying to print like a odd number out of from 0 to 10. Okay, some odd number. Okay, so there is multiple way to do that. So let's say how we can do this by continue. Simple thing, you start the number with 0 using for loop. It will keep doing it unless the number is less than 10, and will increase the number by plus 1. So like I explained in the last part, like what is num plus plus and what is num plus equal to 1. So these both are essentially the same thing. Okay, then what happens that we check if num is like the remainder divided by 2, the num is equal to 0 or not. So let's say if it's 0. Okay, so now we will start from num is equal to 0. Okay, num is equal to 0 will start, and this is 0. Okay, so this is 0. Then what it will do, it will continue means don't run rest of the code inside the loop, so will not run this code, and again the control will go to this for loop. Okay, so then what it will do, the number was 0, it will increase the number by 1, so the number will be now 1. Okay, then again it will be checking, so this condition is not true for the 1. Okay, then what it will do, it will print the test statement, so we'll get the output as 1. Okay, then what it will do, again it will increase the number by 1, so now number is equal to 2. What will happen if again it will check this particular thing and it's true? Okay, it's true means it will encounter the continuous statement, and what the continue means, don't run any line of code after the statement, and the execution goes to, means the control goes to in the beginning of for loop. So number is equal to 2. So what the for loop will do, the number will get increased by 3. Okay. So number will get increased by 3, and repeat the same thing, and this particular line of code will not happen, then it will print 3. So it's in this way you will get this particular thing as output. Okay. So whenever the continuous statement is encountered, the simple thing is that don't run the rest of the code inside the loop, and send the control whatever the means, like the way code is running, the control to the beginning of the loop. Beginning means the thing will start from here, whatever the value of num will be after increasing. Okay. So this is what the how the continue statement works. So this is difference between continue and break. So if you are doing break statement, the loop will not be run anymore. So the control will come out of the loop. Out of the loop means this particular out of this particular block. So let me know if you have understood it correctly or not. Okay, so yeah. Mhm. So, I did actually found a questions based on a loop thing. So I thought I should discuss, because we have actually covered a lot of concept related to loops, and then we'll see function. So this is a question based on the loop, mainly loop thing. So let's discuss this particular questions. Okay. So this is actually, I think, explanation part question. So it's written that this is from the CMI, I think, 2021 paper. So you have to write your answer with a short explanation in the space provided for the questions in your answer sheet. So this is short explanation questions. So there can be questions of like MCQ type, or there can be explanation based questions, which is called subjective questions in the paper, and all those things. Okay. So things that you have been written a block of code, and some syntax is also written, like a modulo b represent the remainder when a is divided by b. For example, if you divide 23 by 10, you will get the remainder as 3. And this particular double sign represents integer division. So integer division means 23 divided by 10 is 2. No, it's like 5 divided by 2, it is equal to 2. So it will just, you can say that it will just remain return the quotient. Okay, so that's it is asking what will be this particular value is. Okay, so it's a function here. So just don't put any attention on the function. Just see that a variable n is passed here, and n here is 2021. So n here is 2021, and now you have to tell if n is 2021 here, what will be the output of this particular code. Okay, so we'll discuss function in a minute. So just for now, this particular program can be done with the help of while loop. Okay, so just let's see how we can trace the output of this particular code, and we can do that there. Okay. Okay, so simple things that when you will start tracing the output of particular code in the exam, you have to just start from whatever the n is. So n here is 2020. Okay. Now the second thing is that we are initializing some variable. So it's not clear why we are doing this. Why we are initializing answer is equal to 0. Why we are doing x is equal to n. But for now just do this. Answer is equal to 0, and x is equal to what you could say n is 2021. Okay, so just we did this. Now we come to the this particular for loop. So it's written that if while x is greater than 0, so what is x here? X is 2021, it's still greater than 0. So in the first round x is greater than 0, then y is equal to x. So you can write here just x is equal to what is here 2021, and it's a greater than 0. So uh, while y is equal to, what will be the I? Y is equal to 2021 modulo 10. Okay, so we know that this particular modulo thing gives you what you can say the remainder. So you will get here y is equal to 1. Okay, so we will not be writing this thing again and again, just you can do this thing in mind. So just write y is equal to 1, and then answer, what is answer? So I'm writing this ans for the answer is equal to answer into 10 plus y. So like answer is equal to 0. So when you initially multiply 0 with the 10, you will get 0 and plus y, what is y? 1. So answer is initially 1. Okay, and then x is changed to x is equal to x integer division 10. So 2021 integer division means it will just return the quotient, which will be equal to 202. Okay, so this is what we have after the first execution of the loop. Then in the second execution, we'll start with the this particular x. So what the x is now, x is equal to 202, which is still greater than 0. Okay, now y is simple thing. Y is modulo 10. So modulo 10, it will return 2. Okay, 2. Then what is answer here? Answer is equal to answer into 10 plus y. So what is answer here? Answer is 1. Answer is 1 into 10 means into 10 plus 2. It will give you 12, right? And what is x again? X is 202 modulo digit division 10. So it will give you 20. Okay. So are you just seeing a thing, what you can say, a correlation between what is happening here? The thing is that each number getting sliced one by one. So first we sliced one, then we sliced two, and it's getting appended in a way, like in opposite way. So you can see this 2021, if we just take two integer from the end, it will be 1 2. So like essentially we are just seeing that it is trying to reverse the number. So just proceed one more step for the thing. So x here is 20, because you know that x here is 20. 20 is again greater than 0. Now you need to do this thing fast, because if you are just familiar with the program, just you can do this fast. It's not like I'm explaining it in the 5 minutes, so you'll also be able to do this in 5 minutes. We will do this thing in fast, because obviously we are not explaining, but you have to write this way, because this short explanation thing is important. And like if you explain this way, the short explanation, that's how you are going to get the full marks. You just don't they just don't expect the answers. So the simple thing is getting 20. Y again, y, what is y? Y is like x modulo 10, so it will give you the 0. And then answer is y. Answer will multiply the 10 and plus y. So 120 plus 0, which is equal to 120. And what is x here? X here is modulo division 10, which is equal to 2. Okay, and then again x equal to 2 is greater than 0. Still it's greater than 0. So equal to y. Y is what? Y is modulo 10. So it will give you 2 only. Answer is uh, 120 into multiply by 10 0 plus 2, which is equal to 1 2. Sorry. uh, 1202. And then what is x here? X is multiply or do division, it will be 0. Okay, so now at the end of this particular execution, if you again run the code, x equal to 0 will not be greater than 0. So this particular for loop comes to end with the answer. That answer now here is what? After the first for loop end, the answer is answer is now 1202. You can see that it's exactly the reverse of this number. And what we are doing, we are storing x is equal to answer. So it means x is equal to, now the value of x is equal to answer. We have still our original n, and answer is changed by, so like answer is getting changed by, what is the answer into 10. So 1202 into 10 means 0 plus 1. So it means 12021. Okay, so this is what you have original thing as answer. Okay, so after this particular line of execution of this particular code, we have this particular thing. Now we have again, I think, one more for loop. Okay, so we have again one more for loop here. Okay, and what is this thing is doing? If you just see this particular thing, this is similar to this particular thing. This both the code are similar thing. It's not any difference. Everything is similar. Okay, and what is the output? Taking x here, x is also the answer, and answer is what you have, this particular thing. So what this particular code will do, it will do the same thing. It will just reverse this particular x, which is 1202. It will reverse as 2021. Okay. Okay, so means like, but the thing is that here answer is something different. So if you have just understood this up to here, if you don't have any questions up to this particular part, just let me know, because I will erase this thing and I will tell you what is happening inside this particular next block code. So guys, is this thing clear for the first part? Anyone? Any question? If you have any questions, let me know. If you don't have any questions, see, it's okay. Uh, Guys, if you have any questions, just let me know. Okay. Okay. Others, please, if you have any questions, let me know. Okay. So if you're getting it correctly, then just move to the next part. So like it's good key if as thing you as you are getting familiar to the concept you are trying the question. So for the explanation part, you actually need to write the explanation, and this is how we will get the answer. So like in the CMI paper itself, it may happens that you don't know the answer to some questions, but if it's a subjective part and we're still trying it, there are good chances that we'll get some marks, and you should do that. Okay. So now the x here is the answer here is we have 12021, and x here is 12022. So we here have to keep the track of the variables. So next thing is that x is greater than 0, which is, and in the first equation of the loop, y is equal to x modulo 10. So y will be just x modulo 10. It will be this is two part, and answer into 10. So answer is 12021 multiplied by 10, and plus y, which is 2. So it will be given 12021 2. Okay. And now where x will be this particular integer division, so 120, because if you modulo divide integer division by 10, it will give you 120. Same thing again, if you repeat the same code, just one more execution, you will just see what's happening here also. So again, x is equal to 120, it will give you y is equal to 0. Answer is equal to the same thing, 120,212 multiplied by 10 and adding 0, just it will be this number, and x will equal to integer division, which is equal to 2. So you can see that the same thing is happening there. Whatever the number is, it is getting getting reversed. So this will be getting reversed 2021, and same thing is getting appended in the end of this particular number. Okay. So if you just want to do two more step, you can just proceed the same way, and in the next step we will just see, like x is equal to 12. So y is equal to 2 here, because you will do the this modular division, and answer now is equal to 12021 and x is equal to 1. So finally, what is the thing that you are going to get? So finally you are going to get 12021, then 2021. So this is what going to be the your answer. Okay. So thing is that 2021 is getting reversed first, then 1 is being added, and then same thing is getting appended here, because we are trying to reverse 1202 there. Okay. So this is what the particular answer is. So you need to really know, like this thing is not something difficult, because this is simply the modular division and integer division, and you just need to do this thing very quickly so that you can get to the answer. Okay. So there are not lot of questions inside the CMI paper, and you have a 3 hour time. So like 40 questions, sometimes 36 questions. So you can easily do these type of questions quickly in 2 minutes, 3 minutes. So guys, if you have any questions, then just let me know. And if I just clear with the part, just let me know. Yes, I can proceed. Okay, if it's clear now, then we will just move ahead. So this particular thing is the answer that you can uh, match up with. Okay, so we talked about, we just saw that this particular thing here actually has some, like function is written. So just let's discuss some portion of function also inside the C program. Okay, so function is, like let's say we have some particular line of code, and this particular line of code, what we do, we just store it in some function, just store it in some, what you can say, this piece of code we store it somewhere, and what we do, if we want to run this whole set of code, what we need to do, we just need to call the function. Okay. So function means it's it may happen that inside the in the maths also, let's say this particular thing is function, and uh, you know that if you want to calculate value of any number from for any x, just put 2 there, and what it will do, it will just do the calculation based on 2. Just put -3 here, and it will do the calculation based on -3. So this is what of with the function also. You will just store a general formula, general form, and if you want to get this particular thing evaluated, or just want to run that particular line of code, what you need to do, just need to call the function, okay, and give some parameter. So like here 2 is the parameter, -3 is the parameter, so we have also parameter with the our function. So everything that is with the mathematical function we have also in the programming, okay. So let's say we are, like itself, main itself, I was telling from the beginning that main itself is a function. So main is the function. So let's say when you run the particular C code, actually the execution start with the main function. So whenever you run the code, main function will be run by default in the beginning itself. So everything start from the main, and whatever the code written inside the main function get started executing line by line, okay. So that's why main is the by default will run first, and if you are trying to call some function inside the main, you will just getting the function called, and that function will also be getting run, okay. So what's like the things that how to define a function. So like function is just like we do, you need to write some return type. So like what the function will be returning. So let's say if it's returning int, you can write int then the name of function. If it's returning float, you can write float then the name of function. And if it's returning like say char, you can write the char then the name of function. If it's not returning anything, you can also write void and then the name of function. So these things are there. So like void print message. So print message is the name of the function, and void is the return type. So this is the return type. What will the return type, okay. And like in in Python there are different way to initialize a function. In R language there is different way. In C++, both the things are almost same. In Java there is different way. So these things are actually depends on programming syntax, whatever the language is. But thing is that more or less overall the thing is there will be some return type, there will be some name of the function, and there will be some parameter. So if this particular line of this particular bracket is empty, if there is not written anything, it means no argument or no parameter is being passed in the function. So there is no parameter. And if it's written something, we will see how to deal with those parameter. So what happens when this particular line of code is run? Actually, the execution go to main. Main will start running the code. So it will first encounter a function. So to call a function, like this particular thing that we do here is called a definition of function. Okay, we define a function. We define a function, okay, and we actually define a function out of the main program. So you can see that this particular thing, this particular line of code here is enclosed in a since this curly braces. This is a part of main, and this particular part is exactly out of the main program. Okay, so this is how we define a function. We define it outside the main function. So what the function is, how to define function, the return type, the function name. If you want to pass some parameter, just do it and write some C programming, C block of code. Okay, just like the way we have written here. So when the program is called, the print function, print message function is called here. So what it will do, it will just go to the print message and will try to run the code line by line. So in this also you can see that this is only single line of code. So just you will getting the output of this particular thing. This is not, this is getting printed using a function. So simple thing, function is not like anything that you need to just do some brainstorming. The simple thing is that you just define some function and you call some function. Okay, you call the function inside the main program. You can also call this function inside another function also. So let's say we just define some other function, and you want to call this particular print message function inside that function. You can also do that. Okay, so the overall idea is to just a simple thing, just define the function, call the function. Okay, and this is how we call it, just function name. If it's there is some parameter, just pass it. If it's empty, then put it empty and then semicolon. So this is how we actually define a function. So guys, if you have any questions, then just let me know. Okay, so if you don't have any questions, then just let's see some important points related to function. Okay, so some important point is that first, any C program contains at least one function. Like the main function is always there. That's why we are telling that any C program will contain at least one function. So like sometimes you will be seeing that written int main, So because we want the type of return type to be integer, sometime will be written void main, so we don't want to return anything. So like if you don't want to return anything out of the function, just put void main. If you want to return the integer, return means it will do some calculation and will return the return of value. Okay, so this is what the return means. If a program contains only one function, it must be main. If a C program contains more than one function, then one of these function must be main. Okay. So like main is the always there, and whenever a program execution start, it will always start with the main, because program execution always begins with the main. Okay, there is no limit on the number of function that might be present in a C program. So like you may define 10 function, you may define two function, you may define one function, you may define thousand function inside a C program. So like particularly when software is made, so like the way you use a web application or other software, there are multiple types of function retained. So like maybe 500 function, different function will be there. So these things is actually get complex when you design a complex software. Each function in a program is called a sequence, specified by the function call. So like I told like in the main function, main will be run first, and like main function there are 10 functions. So let's say this is function one, this is function two, and dot dot dot. So whatever this particular sequence is, the function will be getting called in this particular fashion. It's not like if we written one and two, then two will be called first, and one will be called in the after the two. This will not happen. So whatever the sequence is specified in the main program, it will be getting called in that fashion only. Okay, each function has done its thing, it control return to main. So let's say this particular thing, so let's say this, okay, so this just go ahead, and this particular thing is return. Okay, so this particular thing is called, and this particular message is printed. Then what happens? Then the control again returns to the main function, and it will start running the code that is written after this particular function. So you can say that after this particular function, there is no such printing or some anything any code. So it will run out of the, so it will means exit out of the program. But the thing is that whenever a function is called, after the function is getting executed, the control returns to the main program. Okay, so the control returns to the main program, and it will start running the code after that particular function. So this thing is always there. Also you can call any one function within another function. So like we are itself doing it now, we are just calling a function inside the main function, and you can also define some other function, and you can also call those functions inside some other user defined function. Okay, so these things are always there, and it always leads to some complex program. And any function can return only one value at a time. So like we'll see how to return a value using a function. Okay, so let's say we are defining two function here, for addition and for subtraction. Okay, so what we are doing, we are taking two numbers integer from user, we are just taking the input, and we have defined two particular thing, add or sub, and we are calling a function addition passing a and b. So this is how we pass the argument or parameter inside a function. Okay, so what this particular thing is means, you are passing a as the one parameter and b as the another parameter. Okay, but you need to define what this a b is, if it's an int or float or character, but you don't define it here, you define it the function definition. So you can see that this is a function definition of addition thing. Okay, and we have exclusively written that int addition means addition will do something, some addition, some particular thing, and will return an integer. And then what we have written, int num1, int num2. So there will be two numbers, num1 and num2, and both the numbers will be integer. Okay, so overall this is the overall idea to define a function. You define a return type, you define the what's the each parameter type is, whether they are going to be integer, whether they're going to be float, whether one is integer another is float, anything can be there. And like it's always happened that any particular function is character, any particular function is integer. So this particular thing is always there with the function. So this like there are a lot of things to, if you're just reading for the function for the first time, the another most important thing also, the thing is that there is no need to define this particular variable with the same number. So like we have mentioned a and b because taking integer a and b as the output, but this thing is not there. We have defined num1 and num2. So like it's also true in the it's also true in the what you can say, in math also. So let's say if we define fx is equal to x square plus 1, this particular thing fy is equal to x square y square plus 1. So whatever the value put here, you also put here, it will give the same result. That's why like in the definition, you may take the same thing, may just put a and b, but you also change the variable, and whenever you pass the argument, that particular value will be calculated. So if you just someone write fz is equal to z square plus 1, the both function overall everything is the same thing, unless you change this function name. So let's say if something is fx and something is gy, then if it's the same thing also, okay, then also these are two different functions, because you change the one is the f, means the first function named as f and second function named as g. Okay, so this thing is important, and mainly because people get confused ki what, why this number is written here, why not a or b, or why not something else. You can write any number, anything here. So whatever you are writing here, whenever you pass some argument, it will be get cast up with this particular name. Okay, so when you call addition ab, so num1 is equal to a and num2 is equal to b, and what it will do, it will do this calculation num1 plus num2, and it will return some value. Okay, similarly in the subtraction part, this we are calling the same thing a and b, and this number first will be a and second will be b, because in this way this is getting passed. Okay, it will do some calculation, return a value, and this particular value whatever it hold, it will get stored in the add, and this particular value will get stored in the sub. And when you will print this particular thing, you'll be actually getting addition and subtraction of two numbers. So like in broad way, you can say that this is how a function is defined. You just pass some parameters, you do some calculation, you return something, and a particular return something is getting stored in some particular variable. So overall this is the way actually things is done. So if you have any questions, then just let me know. Okay, okay, no problem. So like just let's say some complex example of function. Okay, just a little bit complex example. So the thing is that here, simple thing, just like whenever you are just studying with function, it may happen that function is defined in the beginning, or maybe the function is defined after the program. So whatever you need to see, just start looking towards the main thing. What is the main function? Okay, so just simple thing that you can read this particular thing. Okay, int a is equal to 10, b is equal to 20. So there are two numbers 10 or 20, and there's a function int m which is defined as max ab. So there's a function max ab where a is getting passed and b is getting passed as argument. Okay, simple thing. And then it's trying to print whatever the aim is. So now we need to find what the max is, where the max function is located. So you just see, okay, max function is located here. So what is happening here? Here there is two argument, int x and int y. Argument or parameter are the same thing. Okay, argument or parameter, this is what we call when you pass something in the function. If x is greater than y, so like you can, if you have really traced what the max is, max will be returning an integer. Max will be taking two integer as the input, and what it will do, it will just compare two things. If x is greater than y, then return x. Okay, so let's say we are inputting to number 10 and 20. So this is a, whatever the a is, a will be treated as x because it's the beginning. So x is equal to 10 and b is equal to 20. So if x is greater than y, it will return x. So it will return x. So but here the thing is that x is 10 and b is 20. Then what it will do, go to the else condition, and it will return y, because if x is not greater than y, obviously the greatest of these two is y. So this particular thing is trying to calculate the greatest of two numbers using function. So if x is greater than y, it will return x, and if it's not greater than y, then it will return y, because y is the largest. So like you can also, just the way the program is done, you can return the values based on some condition. So like some condition is true, then return something else. Some condition is false, then return something else. So this particular thing is always there, and when you will run this program, you will get the 20 as the output, because it's trying to calculate the maximum of two numbers. So like whenever we try to explore the function inside this, you will see a lot of things related to this type of questions. Okay, but the basic idea is only one thing. You will have some return type. In the beginning itself, I was saying, in the beginning type, you will have some return type, some argument, and you will return something after calculating some particular piece of code. Okay, so guys, any problem, then just let me know. No, you can return anything. Like it's not like you just return only what is mentioned here. So like if x is greater than y, you want to return true, you can also return true here. Or you want to return some message, you can also return some message here. So there are multiple ways to return something. It's not like only integer or float. Okay, so here Okay, so here we know like we just saying that ki we are trying to find maximum of two integers. Okay, so if you want to calculate maximum of two integers, then whatever you will return, it will be an integer, right? That's why you are writing an integer. So let's say you want to return a float here. So let's say you are trying to you are defining a function. Okay, you are defining a function to find the simple interest. So we name the function si. You enter three variables. First one is p, then second one is n, and sorry n, and then third one is r. So you do this int r. Okay, so you write float here because whatever you will be returning will be type float. Then you take three argument, which is p, n, and r, and then you know like whatever the p and r is, what you do, you define the this particular thing float si is equal to p, n, and r. So there is star and divided by 100, and then what you do, return si. This particular thing, this is a small si, so this is small si. So this particular thing is float, and that's why since you are returning a float, you need to keep the return type as float. So whatever you are returning the variable, whatever its type is, if it's an integer, you have to keep it as an integer. If you want to return something, if it's a character, you have to return your character. So whatever you are trying to return here, that particular thing will be there. Okay, so initially we are returning an integer here. Okay, that's why we kept here as int. If you don't want to return anything, no problem, just read here void. Void means you don't want to return anything. Then what you need to do, you just print some message. Okay, like the way you know, like you can say that this particular program, uh, we don't return anything now, we're just trying to print a message. Okay, so we return void, and we also see that we are not returning anything. Okay, so is it fine? Okay, so like after the function, there is something called a recursion. Okay, so like in the C itself, in the book, let us see, still there are a lot of questions given based on the program, obviously based on the function also. So like one easy practice with the function is that whatever the program you know till now, you can just implement those things in the function. So let's say you're trying to find two addition of two number, you can do it add using function. If you're trying factorial of two number, you can do it using function. Or if you want to find some other thing using function, you can do it using anything you want to write, you can do it using function, and that will allow you to see what is the like what is the integer type, what is the return type, or how to get the pass the parameters. If you get some error, obviously you can just try to get understand error. Okay, also one thing, like whenever you're trying a code and if it's getting some error, just try to read the error. Okay, whatever the error is, just don't think ki, okay, this error has come, okay, just let's search on the internet or ask someone. Just try to read what's written in the error itself, because like if you are doing some program in the real life, there will be a lot of errors. So like when I was learning web development in my first year of bsc, actually we used to solve errors for like one errors actually takes 7 days 8 days to solve. Okay, and we just keep reading about something, just try to understand what's happening behind. We just also search on the internet and see what's the error is all about. So it's all about understanding the error. So the thing is that ki whatever the program error is coming, just try to read at least whatever it is saying. It may happen that you have written some variable as wrong, or just you have missed some semicolon anywhere. So these errors you have to see, and what's the error there, you also need to see what's the error is there, what it's written. Maybe it's writing something, some particular like syntax error or something else. So this thing is actually sign up a good programmer, because you are trying to also read error and sort out by your own. And if you don't find anything, you just see on the internet also. But things that just try to understand what's the error is all about. Okay, so the thing is that here just here is a example of a recursion. So recursion is the same thing that just like calling a function. So let's say you have a function, okay, and you want to call a function within the same function. So it may happen that na ki, let's say ki you want to repeat some task. Okay, you want to repeat some task, and actually task is of same type. So you can just keep calling the same function again and again. So a better example is to, let's say, factorial of a number. So let's say you want to calculate a factorial of 5. So we know that 5 can be written as 5 factorial can be written as 5 into 4 factorial, right? So initially this program turns out to be 5 into fact of 4. So you can see that this particular, to calculate the factorial of 5, we also need the factorial of 4. Okay, and in the same way we can extend this thing. Okay, so we can now write same thing for the 4 also. 4 can be written as 4 into factorial of 3. Okay, and 3 can be written as 3 into factorial of 2. So you can see that whenever we are trying to find the factorial of some number, we are actually getting calling the same function on a number less than that. Okay, so this is how you get the idea to apply recursion. So it's like to apply the idea of recursion, just see what is that particular task that is getting run on the smaller number. So you can see here that the smaller number is 4, and it is getting run here on the 4 itself. Okay, so to run the factorial, the simple thing is that just trace the bigger part. The bigger part is this, and also trace the smaller part. Okay, so let's say how we can write this particular function. Okay, just simple thing. So let's say we are trying to the same program is that, just let me write in my own terms. So let's say we're trying to find the factorial of n. So factorial will be returning some value of integer, and we're taking any n as the integer. Okay, so let me just sorry. So let me just do this thing. Okay, so it will be int factorial. Okay, and then int n. Okay, so it will take integer, and it will return an integer. Okay, so obviously let's say n is equal to 0 or n is equal to 1. In that case, what you need to do? So we know that 0 factorial is 1, and 1 factorial is also 1. So in that case, just do a simple calculation. If x double equal to 0, or x double equal to 1, what you need to do? Return 1. Okay, this thing is clear, because any user is giving any output. So if it's a 0 or 1, we know that the factorial is 1. But in other condition, so let's say now we come to the else part. Okay, else part. Else part, let's say the user want to calculate the factorial of n. Okay, factorial of n it want to calculate. So in that case, what you need to do is simply know that to calculate the factorial of n, just simply return this particular thing. Okay, so if so like we can just define an integer here. Int is equal to some number factorial f, and f is equal to what, this that particular number, which is n, into factorial of n minus 1. Okay, and at the end, what you need to do, you need to return if outside the loop. Okay, so this particular thing is there, that can be used to find the factorial of a program. So let's see how this particular code is running. Okay, so to understand this part, the simple thing is that uh, when the user input 5, 1 or 0 is clear. When the user input 5, it will come to the else part, and it will be getting f is equal to 5 into factorial of 4. Okay, factorial of 4. But you know that factorial of 4 is not with you. So what it will do, it will again call the function. So it's it's calling the function inside itself. So अभी तो 5 का factorial calculate नहीं हुआ है, but it will calculate it will call the function on the 4 itself. So the thing is that, now the thing is that sorry, now the thing is that it will get called on the 4. So it will be 4 into factorial of 3. Okay. Obviously, you don't have factorial of 3. It will be getting called on 3 into factorial of 2. Obviously, you don't have factorial of 2. It will getting called as 2 into factorial of 1. And when you will call factorial of 1, it will be getting return as 1. So it will be 2 into 1, which is equal to 2. Now we have this particular thing. This will be 2. So now it will be 3 into 2, which will be 6. Okay. Now this particular thing will be 4 into 6, which is 24. And now this particular thing will be 24 into 5, which is 120. So this is how everything get calculated in step by step. So understanding any recursion problem is a little bit difficult, and especially the coding any recursion problem, because the simple thing is that sometimes the complex problem don't actually get understood, but the recursion part is simpler. The main thing is that there is a base condition. So there is a base condition. Base condition means what should happen when some condition is by default true. So we know that if x is equal to double zero, or x double equal to 0, or x double equal to 1, this is the base condition. Base condition means it's always going to return some fixed number. It is not going into recursion. This is not going to recursion. And then there is some recursive part. This is called recursive part. Recursive part means what is going to be in the recursion. So we know that this particular thing is going to be in the recursion. Okay. And if you call factorial of 5, it will call 5 into factorial of 4. But factorial of 4 is not with us now. It's just calling the function same on a number less than that. That's what we discussed here. And for this to be done true, to find this particular thing, you need to find this particular thing. So this is still in the memory. So like it happens. What will there is a stack of memory. A stack means there is a particular what you can say table, a small table, and whenever you are calling a function, it will just get stacked up one by one. So this is a stack of memory. Okay. So what it will store there? It will store there fact into 5 into fact 4, because fact 4 is not with you, and it will then call the fact 4. So this will be 4 into fact 3, and this will be 3 into fact 2. Okay. And until this particular thing are not calculated, it will be all stored in the memory, because computer wants to keep a track of thing that you are trying to do. And here will be fact 1. So once the fact 1 is calculated, this particular thing will be erased, and now we will be left with fact 2 into fact 1. Once this thing is calculated, this will be erased. Once this calculated, this is erased, and finally you will get this value, and this whole over thing is erased. Okay. So this is how a recursion works. Whenever you call recursion, everything whatever you are calling again and again, it will get stacked in the memory, and then again it will start running this particular thing. Whenever you were just stuck with the base condition, it will run the base condition. It will take its output, and it will just start evaluating things, like side by side, everything it will evaluate, and finally will get to the result. So this recursion is something typical, different, difficult, but but understanding the output is simple. Just you need to find the base condition first inside the program. What is the base condition? And just try to think which part is the recursive part. So there is some recursive part. Recursive part means where the same function is getting called again and again. The same function is getting called again and again. So this is what the difference between the recursive part and the base part. There is a base part. Base means there will no any recursion part there, and recursive part means there is the same function getting called by some different means. Okay. So here same function is called x into x minus 1, like the n into n minus 1. So this is what the formula factorial is, and this is how it is getting calculated. So guys, if any problem you have, just let me know. Because if you have any problem, yeah. Okay, so the overall idea of the recursive thing is that we need to call the same function inside itself. So let's say we have a function, let's say factorial, and we want to call the same function. If we when we call the same function inside itself, it's called a recursive function. So like anyone may ask, what is the use of recursive function? So let's say we want to calculate the factorial of 5. So instead, factorial of 5 can be written as 5 into 4 factorial. So this means if you want to calculate the factorial of 5, you need the factorial of 4. Similarly, if you want to calculate the factorial of 4, you need a factorial of 3, and then the same way. So we actually, when the problem is of this type, we can actually do this thing using the recursion, using the help of recursion. Recursion means repeat the same task, but on the calling the same task, calling the same function, but on a smaller set, a smaller number, a smaller anything smaller. So let's say we want to calculate a factorial of n, any number n. So the simple thing is that if n is equal to 0 or n is equal to 1, we know that the particular thing is going to be 1, because the 0 or 1 factorial is 1. But if it's not 1, let's say it's n is equal to 5, then what we need to do? We need to call 5 into 4 factorial. Means so calculate the same function on the smaller number. So we are doing, we are calling f is equal to n into fact of 4. Okay, and we just again, when the fact 4 will come, it will again call 4 into fact of 3. When the fact 3 will come, it will again do 3 into fact of 2. So like this thing is getting calculated this way. So let's say we call f is equal to 5 into factorial of 4. So since we don't have factorial of 4 with us, then what it will do, it will just call factorial 4 will again call 4 into fact of 3, and this particular thing is getting stored in the memory. So this thing will be still in the memory. Then 4 is 4 into fact 3. Fact 3 will call 3 into fact 2, because this particular thing is still be going on, and this is, again, is getting stored. So this all things will getting stored in the memory once we get the factorial 2 till the point of factorial 1. So we will be getting factorial 1, and we know that if x is equal to 0, means whatever this particular thing, this n is, if n is equal to 0, so let's say put n, okay, this is n thing. So if n is equal to 0, then we will return 1. So when we will get the factorial of 1, we'll get the factorial of 1. We now we have this factorial of 1. So now we can calculate factorial of 2, which is 2 into 1. If we have this particular thing, this thing, using this particular thing we calculate this way, this thing we calculate this, and this thing we will calculate this. So this thing will be still in the memory, but once we get a factorial of 1, everything will get calculated backward, and at the end we will get the 5 into factorial of 4. Now we have factorial of 4 with us, so it will be getting 120 as the answer. Okay, so this is how we actually things run. So in any case, any factorial program, just sorry, in any recursive program, there are two things that you need to focus on. The first is the base condition, and second thing is the recursive condition. So just you need to find what is the base condition there and what is the recursive condition, and then you can solve that particular question. So is it clear now? Okay, any other questions, then let me know. Uh-huh. Yeah, yeah. Yeah, yeah. Okay, so means you are telling if you have calculated this particular thing, whether this thing will be stored in the memory or not. Okay, so that particular thing, whether once if this thing is not calculated, this is still in the memory, and if this is getting calculated, this is being used to calculate this thing backward. So whether this is still in the memory or not, that we need to see, because we can store it in the memory. So let's say we define a array here. Okay, we define array, and what we do here, we just trying to store the values whatever we have calculated so far inside the table. So this way we can store it. So like that case became the part of dynamic programming, and that is always there. But to so you are right, just key, we can do that part. We can just define an array, and we can store that part for the later use also. Okay, so to increase the efficiency of recursion, later some concept of dynamic programming is used. So dynamic programming is something, you just store some values that you are calculating now, and we used in the future for some calculation purpose. So there are dynamic programming is actually a broad part of some greater algorithm. So that thing is not a point to discuss here, but things that you can always store these values, and you can increase the efficiency of this program. So this thing is always there, and a same using the factorial function as a program. If it is it clear now, can you proceed? Okay, so using the same function, using the same factorial function, you can calculate this particular thing. So in math, ncr is equal to this combination thing, n factorial upon n minus r factorial into r factorial. Okay, so using the factorial function, you can make a program in the C or any language to calculate this particular thing. So what you need to do, just define a factorial function and take two numbers as input from the user, n and r. And what you need to do, just call this factorial function. So it's simply like fact of n divided by means whatever the symbol you put here, fact of n minus r into fact of r. Okay, so using the same factorial function, you can also calculate the combination of these two numbers. Okay, so this thing you can also do. So just you can try out this particular thing as the factorial function. There are a lot of problems that can also be done using the for loop, and those can also be done using the factorial recursion thing. So you really need to if you want to practice the recursion, just you can just try to do those particular type of task also. So let's say, let's see there what is happening there. So we have this particular thing as recursive part. So just let's see how this we can do this particular question that has been asked actually in the CMI. Okay, so things that we have some function. There are two variable x and y. So, like I told you, in the in the question paper there will be two things. There will be written pseudocode. Okay, so pseudocode means it may happens that they follow the correct syntax, or it may happens that they don't follow the correct syntax. So don't worry about it. So like there's no written intex or intvoice. So don't worry about it. Okay, so don't worry about it because it's a pseudocode. Okay, the thing is that we are getting past here, so this is the last thing let me discuss, and then we can end the class. So f of 6 comma 3. Okay, so this thing is there being passed, and now it's starting what is the output. So let's say this particular thing is x and this particular thing is y. So x is equal to 6 and y is equal to 3. Just write this thing because this thing is important. So written if y not equal to 0. Okay, so y not equal to 0 obviously, then what it will do, it will return x, which is 6, into f of what is there, 6 y minus 1 2. Okay, this particular thing is, it will return this particular thing. Okay, then what it will do, again it will come to this, since this function is called again, it will again come and compare. Okay, so y is now 2 and it is not equal to 0, not equal to 0. Then what it will do, it will again call the same function, which is x, which is 6, into uh, f, which is f of 6 comma 1. Okay, because y will increase by decrease by 1. Again it's called the same function and it will just do the same thing. 6 y is equal to now since y is equal to 1 here, so y is equal to 1 here, 6 into f of, sorry, f of 6 comma 0. And since y is equal to 0 here, this will be calculated as 1. So this particular thing will be calculated as 1. This particular result will be 6. Since this is 6, this particular thing will be 6 into 6. Okay, so it is 36. Since this is 36, this particular thing will be 6 into 36, which is equal to, I think, 216. Okay. So what you can see, okay, this particular thing is getting recursed on y, but y thing. Okay, x is remaining the same and y is getting recursed on y particular thing. Okay. So whatever your correct answer is, you can put that in. Okay. So do you have difficulty in understanding these questions of recursion? Is it clear now? Okay. Like, so the same thing is that whenever trying to trace the output of program, the simple thing, just write whatever it is given and just trace it step by step. Okay. So it may happens to be the questions of MCQ, but when you will trace the question step by step, you'll just get to understand everything. Okay, this particular thing is getting called on Y. So 6 into something, 6, 5, this thing, this will be getting called something else, this will call something else. And when you'll getting the output, just trace it back. Okay, trace it back and you'll get the result. Okay. So this is how you actually do that. Okay, so I think we have covered a lot of things based on function, recursion, and like tomorrow is Saturday, but since I skipped the class yesterday, so just we'll be taking one more class for the programming section, and we'll be discussing some more problems. Okay, so till now we have been at place where we can complete this thing. So let me just discuss array and some data structure topic that is actually asked in the paper, and we will also do some problem solving skill, and then from the next week we will start with the probability. Okay, so I think this thing is by using the particular thing that we have studied till now, especially the loop and function, actually now we can solve a lot of questions. Like initially I told you about the problem solving skill. Okay, so like problem solving skill is something that whatever you know, you need to use those particular thing to solve the problem. Okay, so till now you all know the basic of programming, so just spend some time with the questions, and I'll be discussing some questions during the class also, and try to see how you can solve those particular questions. Okay, so like it's good that some people are especially trying to solve the questions now by discussing with them, so that's a particularly good thing. But the thing is that everyone need to do this thing. Okay, just not a few people, because if you want to clear especially the exams like CMI, questions will be from the basic topic. It's not like some basic function, some basic recursion, but to solve these questions you need to have patience, you need to keep some practice. Okay, so this thing is there always. And like when I was preparing for the CMI, so I had to be like I had to be lucky, because like everything that was in the course of CMI, actually I had in the my syllabus itself, academic syllabus. So we had C programming in the beginning, we had this Boolean logic as a new chapter. We have discrete maths as a new syllabus in academic syllabus. We had statistics and probability as a new syllabus. We had distribution as a new syllabus. So we read everything in our course structure itself. So I caught myself with lucky. actually had a good background from the beginning itself. But there are selected topics. It's not like you need to read advanced topic, very advanced topic. So just like whatever you're studying, just try to approach the questions paper. So some people are asking that where uh, from where they can get the same question that is asked in the CMI. Obviously, just try to solve the paper only. Okay, we have 3 year papers, I think. So 3 year papers, you will get a lot of insight about what type of questions are asked in which type of person. Okay, so that's why it's important ki, like I don't also know ki which type of book will give you which type of questions, because previous year paper is only I trust most. And whatever the questions are, just try to spend your time to solve those particular type of questions. The only thing you require is the thinking. And if there's some knowledge of the particular thing, by using your thinking skill, you can clear this exam. It's not like you need to know most of the advanced topic, most of the syntax correct, most of the things going in the same direction, same doing everything correctly. Just thinking you can do it. Just and you need to practice it in the day one. From day one, you need to do practice this thing. So simple thing. Just whatever you studied till now, just put your effort, put your try to practice some questions, and we will still discussing some questions in the class itself. Okay, guys. So just we'll do something. I read some other questions, and then we will end the programming section, and we'll just move to the probability section also. So then we'll keep discussing some questions. Some if some topics you find that has not been taught, like like maybe some decision tree, or some, sorry, this particular binary search tree topic. So I will discuss those topics, and you find something else, just let me know. We can also arrange some classes later. Okay, guys. Any suggestions? Anything that you want to convey, and how the class